So here we're taking a look at balancing some more redox equations using oxidation numbers. And this is something that we do have to be good at because when it comes to balancing redox equations, it's about the transferring of electrons. So we have to make sure that that's what we're taking into account. If you're balancing by inspection, so the way you would have learned prior to this, it might not always work out. It could work out every now and then, but not every single time, because balancing by inspection does not take into account electrons. So let's start by adding in our fixed numbers. So we know oxygen is always -2. We know, unless it's attached to a peroxide, hydrogen is always +1 unless it's directly bonded to a metal. And then we'll figure out the rest. So nitrogen has to be +5. So the reason is if hydrogen's 1, you add 5, that's a total of +6. And then oxygen has -2, but there's 3 of them. So we have -6, and that will add to 0. So because there's no charge on our compound, we want it to add to 0. So same thing with the next one. We'll have -6 from the oxygen, +3 from the hydrogen. To make that add to 0, AS has to be +3. Moving on to the product side, -2 times 4 gives you -8, plus 3 is -5. So to make this 0, AS has to be +5. NO2, we have -4 from the oxygen, so +4 for nitrogen. So that's your start. Assign your oxidation numbers, and then you want to take a look at what's changing. So AS is going from +3 to +5. That's a loss of 2 electrons, so oxidation. And nitrogen is going from +5 to +4. So that is a gain of 1 electron. So your goal is to make that the same. And there's only 1 atom on each of these, so we don't have to multiply by atoms. So to make that the same, we'll multiply the second one by 2, so that's an exchange of 2 electrons. So we'll put the 2 in front of the compound. And now that we've accounted for electrons, you balance the rest by inspection. So to balance this one out, we'll just need a 2 here. Moving on to the next one, doing the same thing, start with those fixed numbers. Then figure out the missing numbers. Simple ions will have the charge of that ion. So here, iodine would have to be +5. Over here, chlorine's +1. Over here, +1, and then -1. Now take a look at what's changing. We have chlorine going from +1 to -1. So that's a gain of 2 electrons. And you have, what other one is changing? Iodine going from -1 to +5. That's a change of 6 electrons. Again, each of those atoms only have 1, so we don't need to multiply by amount of atoms. We can just go straight to multiplying the HOCl by 3. So it also has an exchange of 6 electrons. So to show that, put a 3 in front of the compound, and then we're going to balance the rest by inspection. And to have this one balanced, we just need the 3 there. So it looks pretty messy, but all we're looking for is those coefficients in front to balance. Sometimes you might find it helpful to write it somewhere else and then put the numbers. Maybe do a little chart depending how you've learned it. But yeah, let's just keep going here. So there was a typo on this one. This should have been a 2 because it's water. And let's fill in those fixed numbers. And then those simple ions and figuring out the rest. And then that reminder, atoms or compounds alone have an oxidation number of 0. So we have that. We want to see what's changing. So we have iodine going from +5 to 0. That's a gain of 5 electrons. You also have iodine from NaI going from -1 to 0. So that is also an exchange. This time we're losing 1 electron. Then to balance our electrons, we'll have to multiply that 1 electron by 5 to get 5 electrons. And now they're the same. So we'll put that 5 in front of that compound and then balance the rest by inspection. So to balance this one, we'll need a 6 in front of the HCl, a 6 in front of the NaCl, and a 3 in front of water. Okay, now our next one has an example of what happens when we have more than just one atom that's changing. So let's again always start with assigning your fixed numbers and then finding out the rest. So we know oxygen alone will be 0. Nitrogen here has to be -3. Nitrogen over here has to be +4. And now that's done. And now see what's changing. Nitrogen's going from -3 to +7. +4. That's an exchange of 7 electrons. And oxygen is going from 0 to -2. And either way, if you bring it to this oxygen or this oxygen, it's going to -2. So we just pick one to see what's happening. So that is also a gain here of 2 electrons. But notice this time we have 2 atoms that are going to change. So times 2 atoms gives you a total of 4 electrons being exchanged. So now to make that the same, we'll multiply the top value by 7, the bottom one by 4. So we're exchanging 28 electrons altogether. Now to do that, this 7 needs to go in front of the oxygen, the 4 needs to go in front of the NH3, and then we'll balance the rest by inspection. So we'll need a 4 here and a 6 here. Okay. So that is our process. Now we can apply it to some old diploma questions. So here was a 2-part question. So with this one, it's still the same thing. It's asking about what's undergoing oxidation, or sorry, this is reduction. If your reduction rig, you're looking for what's gaining electrons. And if it's gaining, you're becoming more negative. Now just assign your oxidation numbers. So atoms alone, 0, oxygen -2, hydrogen +1, figure out the missing one, so +5. Over here we have +1, -1, +1, -1. So AU has to be +3. Then we have -2, +1, -2, +4. So we've assigned our oxidation numbers. Then see what's changing. We have nitrogen going from +5 to +4. So that's an exchange of 1 electron. And you also have AU changing from 0 to +3. So that's a loss of 3 electrons. So with this first question, because it's just asking about reduction, it is nitrogen that's going from +5 to +4. So nitrogen had to gain 1 electron to become +4. That is reduction. So here the atom that's undergoing reduction is C. If they asked you about the compound, we would have said the whole thing. So then moving on from here, oxidation numbers allowed us to see what underwent reduction or oxidation in that case. And then if you look at number 33, and it says when the equation is balanced using lowest whole number coefficients, then what is the coefficient in front of nitric acid? So now that we have that, we want to keep going with balancing. To balance this out, we'll need to multiply this bottom one by 3, so we can get 3 electrons. Each of these only have 1 atom, so we don't need to multiply by anything else. So that 3 we'll put right in front of the nitric acid, and then we want to balance the rest by inspection. So to do that, we'll need a 4 in front of the HCl, a 3 in front of the water, and a 3 in front of the NO2. Now, it's just asking in front of the nitric acid, so that is a 3. So, as always, I hope you found this helpful. If you did, please subscribe and like. If you would like me to do any type of video on any topic in chem, please let me know, and I'd be happy to do that. Thanks for watching.